Okay, so let's go on with the next presentation, which is about Houdini, release number 15, and Scott Keating is giving us a sneak peek on that new release. Yeah, welcome, Scott.
So I'm going to actually do some live demo stuff to show you some of the new features that are actively in development right now. So you may see some weird things in the UI or things not working properly because this is in beta right now, so it actually is under development. But before I do that, I want to just try and get through a whole bunch of slides here because there are some things that I can't demo on my Surface laptop here because there's just too many particles involved. So I'll try and show you the cool stuff in some of these videos first. Okay, so basically the first thing I want to talk about is what our goals were with Houdini 15, because that's sort of how we approach stuff. What can we do to help our users and what are our goals? So one of the biggest one was scalability. So we wanted you to be able to take sims you've been doing previously and basically make them bigger, because every year people expect bigger and bigger effects, right? That's like an obvious thing. The movies get bigger, the commercials get bigger, so we want that to be able to scale along with your projects. And then the second thing is scalability as well. And that's because scalability means improving our technology just in terms of the solver, making it faster, making it more memory efficient. But it also means adding some new things, like using as much of the graphics cards as possible and things like that, so that studios that aren't using giant render farms can still scale up their projects as well, because we want to make sure smaller studios are able to adapt to this sort of changing environment. And then, of course, as I'm sure you've predicted, scalability is also another main focus for us, which means for people who do have access to these machines, these very large-scale machines, like with 120 gigabytes of RAM that some of these large-scale studios have, we want to be able to take advantage of those machines, so that they can truly scale up to giant numbers. So, what do I mean by scale, just to give you an idea? So if you think about Houdini, I think 10, when we first introduced the flip solver, 5 million particles was like a lot. That was a lot of particles, for fluid simulation. But very quickly, 15 million particles, it looks like crap if it's not at least 15 million particles, And then it's 75 million particles. And in Houdini 13, for instance, 75 million particles was totally plausible. And then there was a huge jump into Houdini 14. Studios started pushing Houdini like crazy, and they wanted to get these massive numbers, 200 million particles. And so then this time we were like, okay, we see where you're going with this. We're anticipating you this time. We're not following along. So we did some internal tests and got up to 3 billion particles in Houdini 15. So we're really trying to allow you to go as big as you're able to go, basically. So rather than being limited by our technology, you're only limited by the resources you have available to do the work you want to do. So let me just show you a quick example here. So this is a Houdini fluid simulation in Houdini 15, and there's just a couple of things I want to point out because it's easier to see in a nice rendered video than it is in a low-res sim. One is just that it looks nice, right? You see, it's a nice surface, everything looks okay, it's interacting with the character. We built some new tools to help you get characters and things interacting with the fluid. But the other thing is this sort of mirror surface that you see before he starts walking in the simulation, and how smooth the surface is. So that's a really important thing to keep in mind, because a big part of making a simulation look good is not just millions and millions of particles, but also putting a mesh on it, being able to render it in a good way. But the main thing I want to point out about this smooth surface, which will come back in a second, is that what's actually happening here is that we're rendering this across 4 separate machines. And you can see just how smooth the transition is between those slices, right? And that's because in Houdini 15, we've created what we call a global pressure solve, which just means that each slice is a completely stable version of the simulation, passing data back and forth between the slices, so that you can do large-scale simulations like this. I mean, you can even see that in a second. He puts his hammer sort of right in the middle of those 2 slices, but there are no artifacts, nothing weird. And I'll talk a little bit more about that in a minute when I talk about surfacing. But for the moment, just think of distribution and how big this is only 4 slices, so you can go for as many machines as you want. We generally find that after about 16 slices, you start losing the benefit because there's so much data being passed back and forth that you kind of run out of just bandwidth, essentially. Okay, so then let's take a look at the sand solver. So again, this has existed in Houdini 14. Our sand solver existed. And the problem with the sand solver, in a way, is really that is really that you have a couple of things. For sand, it's very fine, right? It's not as fine as water, but you still want lots and lots and lots of particles. And so again, we said, okay, how can we make this easier for our users to really scale up? Because this is really just one guy, but imagine an army walking across a desert or something like that. So again, this whole simulation is sliced as well. So now our pyro solver, our fluid solver, and the grain solver can all be distributed seamlessly across your render farm. And it gives you this really seamless, perfect result. So again, no data is lost between it. You don't get seams. And the reason that's important for us is that giving you the technology is one thing, and it's important to be able to do that. But then we also have to make sure that the workflow is smooth, right? Because what good is it giving you all this stuff if it takes you forever to clean up the edges and all this other extra work along with it? And so that brings us to workflow. So what do I mean by workflow? And the most obvious one are tools for TDs, right? We want these sort of low-level tools so TDs can get a lot out of the software, right? They can dig inside our tools. They can play around with sort of the lower-level things, the more TD-style effects. But then also tools for artists, because we want people to be able to use this software who aren't necessarily super technical, so that they can get in, they can learn, they can play around with really interesting pieces of Houdini. And then tools for everyone. And what I really mean by that is something called Houdini Engine, which is basically a way of taking Houdini's technology, what we call digital assets, and placing them inside other pieces of technology. So, for instance, Cinema 4D. If you're a Cinema 4D user and you'd like to play around with Houdini, but in an environment you're already comfortable in, then this is a great way. You can pull in an asset from Houdini and play around with it in Cinema 4D. Same goes for Maya, the Unity engine, and also the Unreal engine. So we're really allowing you to take these pieces and put them inside of whatever software is actually useful to you. And so, okay, workflow. So here's a really good example of one of the workflow enhancements we made in Houdini 15. So this is that fluid simulation I showed you earlier, but you see these little boxes that's sort of representing the surface. So what's actually happening here at the bottom is you can see we're only actually ever loading from disk the blue particles you see in the middle. And you can see the numbers sort of jumping up and down there, 3.5 million. But this whole simulation is 120 million particles. And so if you're working over a network or you have a slow hard drive, which a lot of freelancers do, it's extremely difficult, even if you have the computer to render out 1 billion particles. How do you actually work with it on your machine? So a big advancement we made was something that we called packed points. And so these little boxes are basically little bounding boxes to give you an idea of what the surface is doing without ever having to load any of the data at all. So you can focus on just one little piece. And what that allows you to do for a simulation like this is almost in real time scrub your timeline back and forth. You're loading particles at an extraordinary rate, but you still get enough information to actually be able to work with it. And then on that same note, it's like, okay, now you have that surface and you need to turn it into a real surface. You can't render these particles directly. Well, you could, but you probably want it to be something that looks more like a fluid. So let's just take a look at this example, just a quick sort of R&D style example where we have this object that moves around. But again, you see how it starts out with this sort of mirror finish. And then once it starts moving, you retain tons and tons of detail in the surface. And that's due to our new particle fluid surface workflow. And one of the things that it does is your simulation is automatically generating data. And that data is called vorticity. And we use that to mask out the different areas of your fluid. So as it's evolving, we see where are the interesting areas, where is the place that detail exists, and where are the places where it doesn't matter if there's detail there because nothing interesting is happening. And then we use that to create a perfectly smooth surface like this one. So again, you can see how smooth that surface is, even with the reflections, and how useful it is to have that kind of control using these attributes. And then, of course, because it's Houdini, all these attributes are there for you to use for anything you might like mist or spray or other types of fluid effects. And so here's another workflow enhancement. Again, so the previous one is more of an artist tool, right? A way of making an artist's life easier. And this, again, is more of an effects artist. So we have our guy, he smashes the sandcastle. But if you look at this simulation, you'll notice something, and this is common with sand sims, that really only a very small number of the particles at any time are really contributing anything to the simulation, right? Because the back of the container right now is just sitting there. It's not doing anything. And in previous versions, you would have to continue simulating that sand basically just sitting there, right? So we introduced a couple of new tools, which hopefully I'll have time to demo for you as well, which basically, these red particles are not being simulated, and only the green particles are. But you'll see that this is dynamic, right? We're not just choosing an area in advance. We're actually tracking the movement of the particles and the movement of the character to predict which particles need to be part of the simulation and which ones don't. The other interesting thing is you'll see some of the green particles hit the sandcastle, but it doesn't react, and then it turns on. And again, that's because inside of Houdini, we're tracking all this stuff just using various attributes. Attributes are just data you can attach to things like particles, velocity, and so on. And so again, as a TD, you have this nice convenient tool for making your simulation faster and smoother and run quicker, but then you also have the artistic side to be able to turn things on and off. You have complete control over how this system works. And again, that's really the power of Houdini, giving you these high-level tools, but low-level access if you want it. But then speaking of high-level tools, again in Houdini 15, something we were asked for a lot was tools to help people set up viscous fluids like lava, for instance. And so we did that. We basically added a small tool set for artists to use to jump right into doing effects like this. And this really is an effect that's done basically just by pressing one button. This is not a complicated effect. And so that's sort of the balance that we try and strike in Houdini, is give you low-level access, really detailed high technology tools, but then also high-level tools so that artists can just dive in and start working. And so this tool set basically allows you to do things like heat up objects. So you see here, it's sort of the pig falls on the grill and kind of melts. But then the pig on the right compared to the pig on the left is basically that we also have attributes to say, well, if one part of it heats up, that heat should actually spread throughout the object, right? It shouldn't just stay in one place. And so the one on the right, as it heats up, the heat spreads throughout it, and you kind of end with this pink sludge at the bottom of the container there. Whereas the one on the left actually keeps most of its shape. And then the shader that's attached here is actually just automatically attached to this object when you apply the melting sort of effect. And so, again, all these systems talk to each other. The heat attributes from the simulation are transferred instantly to the shader, where you can do neat kind of glow and lighting effects like this. And then just to end off with, again, the same animation, we have our guy, all the lighting in this scene is coming from that lava. And so because Mantra, this was rendered in as a physically based renderer, the lava was given some attributes to say that it's bright, it's emitting light, and then that's basically it. You don't really have to do much of anything. Mantra sort of take care of the rest. And it's pretty cool looking. I couldn't think what would be in the lava for him to smash, so I'm actually going to end the slideshow there and actually jump over to Houdini to try and show you some of the things that I was just talking about. So let's actually go ahead and make one of these viscous simulations. So you can see, again, the idea that we're talking about high-level tools for artists, but then low-level access for TD. So I'll actually go ahead and put down our pig head, which is an object that comes with Houdini.
Are we supposed to stop your screen?
Oh, you don't see it anymore?
So I think you have to duplicate this primary screen.
Oh, okay. Let's just change. Oh, here we go. Duplicate.
Duplicate, yeah. So now it should.
There we go.
Great. Keep
Changes.
Kannst du mal den hier kurz anhalten? Mach ruhig mal.
Okay.
Warte. Jetzt ist er gestürzt. Jetzt. Ja, jetzt hast du ihn getötet. Jetzt hast du ihn getötet.
Ah, da ist es doch.
Nee, ich krieg die Anwendung da. Jetzt geht's wieder. Warte.
Good.
Warte, ich mache nochmal Stopp zur Sicherheit. Das mag der nämlich gar nicht, ja.
Okay.
We're good?
Okay.
Okay. Okay, so here's our pig head. It's a standard object inside of Houdini that you can drop down anytime you like, anytime you want to cut a pig up. So let's go ahead and use some lava or mud or something on here just to give you an idea of how quickly we can actually set that up. So the first idea is to use, if you're not familiar with Houdini, these tools along the top, we call them shelf tools, and they build networks for you essentially. So I'm just going to turn that pig into a static object, which means you can collide objects with it. And you can see that it's sort of adding nodes down here in the corner. And then I'm going to put down, let's just say a sphere, I guess. Move it up here. And I'm going to just dive inside and then make this object a bit smaller. Something like that. And let's turn this into a viscous emitter. So we have a new shelf here called Viscous Fluids. Here are a whole bunch of tools for artists, and you can see things like slice and distribute using the tools that I mentioned earlier. And what we'll start with is just lava, maybe emit lava. So I mean, it pretty much does what you think it's going to do. I'll just hit enter. You can see it cooking there at the bottom. And then basically we have ourselves a simulation. So I am going to just change something. Normally you wouldn't necessarily have to do this, but it just looks a little better if I do. So I'm just going to add some velocity to our emitter. So we have kind of a nice, interesting looking emitter. These sort of strings coming off here are just the vectors to give you an idea of what's going on there. And maybe I'll make this just a little bit smaller as well, just to make my surface happy. So here we are in our simulation, and this is really the whole simulation. So this group of nodes was made for you by the shelf tools, and then the idea is that an artist who doesn't really know anything about Houdini should be able to come in here and at least play with some values and get some interesting results. And again, I'm going to just go ahead and shrink our simulation domain a little bit here, just because I am on this laptop and I don't want to have it catch on fire or something. There we go. We'll close it off and then just zoom in. Okay, so here's our pig. And I can basically just go, oh, that's probably a little light for you guys. Let me just make the background dark so you guys can see it a little better. There you go. Okay, so I'll just hit play. And there you go. So you can see the particles are changing color. Hopefully you can kind of see that up there. They start out very white and then they slowly turn this orangey sort of color here. And that's basically it. You've basically created a viscous fluid sim sort of that easily. And then by default, this will be surfaced and have a shader applied as well. So let's just show you how you can change this. So just jump to this node here. Oops, not that node, this node. It's called gas temperature update, but you don't really have to worry about that. What it does is does things like cooling. So you can see the cooling rate parameters here. And that's so that you can do things like have objects that cool off faster on the outside than they do on the inside. So again, things like lava, where the inside is insulated and it stays hotter than the outside. Or the temperature diffusion, which I mentioned, which again is how much temperature spreads through the object. And again, all in this one interface here. So we're trying to keep this nice and useful for people who don't necessarily know a whole lot about Houdini. So just to give you an example here, I'm going to turn up the cooling to, let's say, 75% here so that we can cool off the lava faster. And you can see now that it's already sort of turning red before it even gets to the ground now. And immediately we've changed the look of the simulation. It's sticking to the surface of the pig. It's sort of piling up here at the bottom. And it's really that easy. So if you're an artist, hopefully you can sort of jump in and start playing around and doing neat sort of blobby effects like this. But so what if you are a TD? What if you're someone who's like, okay, that's great. That's a nice starting point for a simulation, but I have a lot of lava effects. I have a lot of stuff I need to do. I need to have a little more depth here. I need to be able to get beyond just this interface. Well, again, that's sort of the benefit of Houdini and what we hope people really like about it. So these nodes that I've been putting down, those are what we call digital assets. And so you can actually edit them, you can change them, right? So this one that creates the lava effect, if I double click on it, it actually just has a node network inside of it. And this node network is what does everything that the tool does. In fact, lots of pieces of Houdini are built out of other pieces of Houdini. So in a way, you can think of Houdini as a tool for building tools. So let me just click on this node here called heat and viscosity. And you can see that inside there's something called Vex. And if you're a TD, just come in here and write your own lava solver. It's completely open to you. So Vex is a sort of an open programming language. It's used all throughout Houdini. It's used oftentimes to prototype tools. And yeah, this is like basically a simple system that, you know, again, it's maybe not even quite a page worth of code here. That does everything this tool does. So again, if you're an effects artist or a TD who likes to get more technical, you have full access to everything that Houdini does inside of its solvers. And I think that makes it a really powerful mix of sort of easy to use, but also very, very deep. Okay, so another thing I guess I should show you just while we're in here is that, again, these shelf tools automatically set up these networks for you. So I'm just going to shape this a little bit. Here's our new particle fluid surface tool. You see it automatically builds the surface for you. Oops. And so you can go ahead and render this sort of immediately right away. So it's very fast. You can see that it's an adaptive surface here, so we're saving polygons along the way. And if you want to get even less, you certainly can do that as well. Yeah, so this is just to give you an idea of how much that shelf tool actually did for you. It built a lot of these networks. It prepares everything along the way. So something I didn't get to talk about in the slides, because I wanted to actually show you it live here, are some of our new crowd tools as well. So crowds were new in Houdini 14, and we've really sort of extended it to some new stuff in Houdini 15. So again, I'm just going to use a shelf tool to set up an example. And that's one of the other things that's nice about this system, is that these tools can encapsulate things for learning, essentially. So things like, how do I set up a crowd simulation? You know, how do I actually do that if I don't know anything about this? Where do I start? So we can basically give you these pre-built scenes right here in the shelf tool that allow you to get a feel for how it works right away. And so here you can see some crowd agents, we call them, these guys. And the nice thing is that we use a very special sort of primitive in Houdini called an agent primitive. And that allows you to have, like, you can see even on my laptop, the performance that I get. I think there's 500 of these guys. And so you get a fairly significant amount of performance out of something that's pretty heavy. The idea being we want you to be able to scale up even on a modest machine to tens of thousands of these things in the viewport, so you don't have to render or bake things out. And you can just really come into your scene here and very easily change the number. So again, I think there's 200, so let's go to 500. Yeah. But again, you can see, like, even in this case, pretty easy to work with. I am going to turn it down here just because I don't want to kill my laptop, but it will actually run just fine. Okay, so let's take a look at what this simulation is doing. So the main thing we added in Houdini 15 for our crowds, and again, this is simulating live right now, is we added something called a Ragdoll support. And so that means your agents can run, and they can run into things, and they can start falling to the ground. So you see there's a guy in the back sort of falling down. These guys are running and collapsing and doing sort of interesting things. This guy is kind of funny here. And so, yeah, so you see lots of interesting stuff. So this is important because a lot of times crowds are used for things like just things in the background. You need a street full of people. They're not doing anything particularly interesting. You just need them to walk around. But sometimes you want them to get hit by an explosion, or somebody throws a boulder at them and they need to be able to fall down and trip up and do interesting things. Something that's worth noting, by the way, is that we automatically cache our simulations as they're running. So once it's actually simulated, you see we get very fast playback of this stuff in the viewport. So I'll just briefly show you what it looks like inside the simulation itself. And again, just remember that I just did this by setting up this one tool, so you can really get into this pretty quickly and start playing around with it. So this is basically what our crowds simulations look like. And it maybe seems a little bit complicated here at first, but the basic idea is that you have something called a state, and a state is just an action. So in this case, you can see it's called a run. And that's all they do. When the agents are in this state, they run. It's sort of really basic sort of trigger logic, more or less, a state machine. And so in one state they run, and then in another state they turn into a ragdoll. And that's really it. Those are the two pieces of this simulation. And you can see them represented by these two nodes. And then the only other thing we do in this simulation is trigger them. So basically we tell them that after 2 seconds, you can see this time here, we want you to go from run to ragdoll. So in a way, even though this kind of looks complicated, it's actually like building grammar. You're saying, I want these guys to be able to walk, and then after 2 seconds, I want them to turn into a ragdoll. And you can really think about it like that, like building grammatical sentences for things that you want to happen. And so it's sort of the way we could best think about how to do this in a simple way, because ragdolls and simulations for crowds are quite complicated, but we want you to be able to get in there and really start using it immediately. But once again, if you're interested, dive inside these nodes and then start playing with the underlying structure of the simulation. It's all completely open to you. So let me show you how we actually set up these guys, because obviously we just opened this thing and there was people and they had rigs and they had simulation data and all this stuff already attached to them, right? So it kind of makes it seem like, well, that's too easy. There's no way that's how easy it is to set up a crowd, because there's just no way. Well, you're right. There is that. That's true. It's not that easy. You do have to do a little bit of work ahead of time. So we have this node here. It's called setup. Just going to dive inside. And basically we have a rig. Oops. So I'll just move it on our guy. And this could be any rig. This doesn't have to be a Houdini rig, and it could be an FBX rig. It doesn't matter. You bring in your rig and your character, and we convert it into an agent. And that's basically what this node does. And what an agent basically is a special way of representing data so that it can be deformed on the graphics card. And that's why this is so fast in the viewport. Is because all of the animation is handled on the graphics card, making it really, really fast. So basically we have this node here, then we have something called agent prep. And this is for doing things like, you can see that we basically says upper arm to lower arm and the hand. And this is so that you can bring in any rig you want with any number of limbs, any number of legs, and you can still apply these same tools to them. So we've basically left it open for you to bring in any type of rig that you feel like. And if you want to do terrain adaptation, so their feet move up and down on the surface, all of that is available to you using this. We'll basically walk through the bones that you provide us and figure out where the feet should go procedurally. This is a little too long to get into exactly how all this works, because I'll probably run out of time, but yeah, you can imagine the idea that you're just giving us some basic markers, like where are the hips, where's the head, and from that we'll calculate the spine, for instance. But then this is the important one, the build collision layer. So if I just go into wireframe now, these are the collision objects for your agent. This is what allows them to collide with things, fall down, and so on. And remember, you're talking about crowds here, right? So 20,000 of these, 30, 100,000 of these guys. So you don't want extremely detailed collision objects, because you're going to run a simulation on that, right? So imagine 100,000 agents times 1,000 bones or something. It's going to be very slow to do that. So you could, but we generally say, keep it relatively simple. You'll have a much nicer time when you're simulating these things. But I guess the question is, well, where do these come from? Like, how is this set up for you? Because obviously, maybe your rig doesn't look like this. Maybe it's a real fat guy, or it's like a troll or something. So you need different shapes. So let me just go ahead and clear out all the settings here, so I can show you how our tool works. So basically what happens is it brings in your rig, any arbitrary rig, and it does a little bit of sort of interesting work to figure out like where the bones are and where the centers are. And then basically it gives you these little handles. So I can just click this bone, and it actually measures the length of the bone and puts a capsule around it automatically. But then you still have to just come in here and edit it. So you can see that, like, I don't care about this little bone because it's not actually going to contribute to the collision. It's just going to contribute to the animation. So I can drag this down, I can change the size of these, and then very quickly, just by going from node to node like this, from bone to bone, you can actually very easily start placing, you know, bones around your character. I mean, really, I've basically made an arm, you know, that quickly. And of course, you can move these guys around as well. So, yeah, you can imagine, you know, setting up characters, how fast it can be done. The other thing that's interesting is that we do this on the actual animation. So if I just go back up to my agent and change his clip to run, and then come back down to our collision layer, you see that it updates to the animation pose. So while you're setting up your collisions, you can also be testing it on the actual animation itself, right? It's not a separate system. And so I'm not going to go ahead, I'm not going to do this whole rig because that will obviously take a little while. So I'll just back up here to our original state to show you another piece of the puzzle here. So okay, we have this rig. It's basically ready to go. It'd probably take you 5 or 6 minutes to give you a basic setup for the ragdoll. But then you need to think, well, where are the joints? Like, I don't want this thing to just, his knees to bend backwards and, you know, those types of things. It needs to behave like a human being. So again, we have some very simple tools here, all automatically sort of procedurally generated by examining the rig that you feed us. And these sort of disks are basically the rotation values. So where can this limb go? Where can it actually bend? Yeah, I need to actually go back to our run because I went to undo. Right, so you can see, like, this is the rotation amount for his leg, for instance. That's how far the knees can bend. And so you can set up your constraints. Again, it's useful to have it on the object like this. Then I just click the node, and I can just drag these handles around interactively. So it's very fast to set up a character like this. So let's just say, maybe I didn't know much, and so I said, okay, let's let his leg do this. And I'm going to let it go to the side a whole bunch as well. So then the question becomes, well, how do I really know how this is going to react, right? Okay, I mean, it's a pretty good visualization, but you're still kind of flying blind a little bit, right? You're just sort of working, you don't know exactly how it works. So by default, we also add this thing called test ragdoll sim. And what that allows you to do is immediately after you've set up those parameters, just hit play and let the guy fall down. And so you can see his leg does something horrific when when he hits the ground there. And so again, the idea is that an artist working on this can, like, really rapidly iterate on their effects, right? You can tweak all the little capsule regions, all the joint limits really, really quickly, and then put it right into a simulation. As easy as that. So this guy now is automatically fed into that simulation that I just showed you a minute ago. So if I was to come back up, zoom out, come over here and hit play. Simulate again now, and now these guys are all using that rig that I just set up. So it really is, in a couple of minutes, you can actually have a working crowd simulation from zero rig to completely rigged and deformable ragdoll. So now they have horrible accidents when they fall down to the ground there. Look at this guy. So the other thing that's really important then is, like, okay, this is great. These guys can fall down. Like, it's funny. It's a lot of fun to play around with it. But, you know, what if you want to do other things where things are interacting more than this? Because really right now they're running and then they're switching to a ragdoll and that's basically it, right? So let me just open a quick example here called Ragdolls. Oh, I'm sorry. I exited out of that too fast. Just load this up again. So what I want to show you basically is how can we have these agents interact with other objects. And so I've sort of lined them up like bowling pins. And I've got this sphere coming in here from the back. So I'll just hit play and basically sort of let you see what happens here. So yeah. So this is actually a two-way interaction now, because those ragdoll agents are true physics objects, right? They can interact with the bullet solver. And so you can do full two-way interactions between the sphere that's hitting these guys and the ragdolls. And then the other kind of interesting thing is that also means that we can trigger the ragdoll effect by running into other ragdolls as well. So if you look on the right here in a second, one of these guys runs over another guy and ends up falling down and tripping over. This guy gets thrown up in the air here in the background. So let me just walk through how that works again. So I talked earlier about these states, right? So these guys have a little slightly more complex behavior. They can walk, they can stand, or they can go into the ragdoll state. So that's pretty basic. But how do we take them from walking to being ragdolls by being hit by something, right? And that's really, again, it's just a trigger. It's called trigger by impact. And you just feed into Houdini this thing called impact threshold, which basically says how hard do they need to be hit before they turn into a ragdoll. And then that's it. That's really it. And then you go ahead and tell it to go from walk to ragdoll, or this guy from stand to ragdoll, and that's it. So again, it's like building sentences. If you get hit this hard, turn into a ragdoll. You can really think about it like that. And just to point out one more thing before I move on from this is, again, so these are the triggers. And you can see we have a whole bunch of triggers here. So things like you could paint an attribute on the ground that change the behavior of the crowd character. So maybe there's an area that's interesting, like a billboard in the background. So you paint the billboard attribute, and the guys who go there go into there, look at the billboard state. Or maybe they're close to another agent and you want them to get in a fight. Or maybe they're running too fast and so they're supposed to trip up. So you have things like, what's the particle speed? What's the current state? How long have they been in their current state? And then a more interesting one, again, for TDs is this one called custom Vexpression, where you can, again, go ahead and make your own. Whatever trigger you want to make, whatever kind of customized version of a crowd sim you want to do, totally possible to do it in this sort of really simple kind of interface here. And then just to end off, I want to show a little bit of the new shading workflow, which is sort of a huge leap from crowd simulations, but nevertheless, let's just very quickly take a look at that. So I'm just going to put down a torus, and I'm going to go to our shops, and shops are shader operations, and I'm going to put down something called the principled shader. So the principled shader is a new shader in Houdini. And what it basically does, is applies a shader that was actually developed at Disney. It's typically called the Disney shader, but we're not Disney, so we can't call it that. But that's essentially what it is. It came right from production. And basically the idea was, for these guys, they were working really hard to make their shaders more artist friendly, so that the artists could get the results they wanted faster, right? Make sense. And basically the method they came up with was this thing that we call the principled shader, which was that they came up with not that many, like 10 parameters, all which go from 0 to 1. And any mixture of these parameters will give you a physically correct result. And so what it allowed the artist to do was really quickly do look development, because if you wanted to paint a map, it's white to black, basically. Super easy to paint the maps, easy to generate the maps. And if you just arbitrarily set these values to any number, you'll still get something that looks like a real object. It may not look like the one you want, but it will look like a real physically plausible object. So just to give you a very sort of obvious example here, a typical problem is something like metal, right? You want something to look like gold, for instance. And usually what that means is you have a preset that's a gold shader or something like that. But if you don't have that, you have to think about it a lot. You say, well, okay, well, gold it's kind of yellowish and kind of gold, and it's pretty shiny, but not too shiny. And then I need to make sure it's a dielectric material, so that means that the color of the metal affects the highlight of the light, so you need to change that. And there's a lot of things to think about. And so really the sort of brilliance of the Disney shader, the principled shader, is that they figured out all of those things for you. So for instance, if I want to make this into something like gold, let's just take not even a particularly good gold color, and then just turn up this metallic slider. and it just sort of instantly looks like metal, right? And so it's a really clever system because it's actually behind the scenes doing quite a lot to the shader. It's changing the index of refraction, it's changing the Fresnel values, it's changing the specular highlights, doing a lot of things. But they basically looked at dozens and dozens of shaders they had built and figured out, oh, whenever somebody tries to make something look like metal, this is what they do. So why don't we just put that in there and let them very easily do it? And so let's say you wanted to do something like a car paint shader, right? So let's make this very metal. I don't know, what's a cool car color? Red. And then we'll make maybe the roughness a little higher. So it's sort of a rougher metal. And then we'll come down to the bottom and we'll just add some coat reflection. And you can see we're starting to get this extra specular highlight now. Maybe the coat has a slightly different roughness than the underlying. And again, very quickly now, you know, I don't know, 20 seconds or something, you can start coming up with shaders. You could say, well, I don't want it quite as metallic. Maybe I want a little more reflection on the front. Maybe I don't want it so rough. And you can really quickly come to really interesting looking results without really playing around too much. So again, the idea of artist tools and technical tools, right? This is a very simple artist interface for dealing with shaders. But if a TD comes along and says like, well, that's great, but I actually need to do a little more work than that. I can't just use those. I have like, I'm making a crazy magic effect or something like that. I need some more control. You can come down to our material shader builder and then put down the principled shader in here. And so now you have it in a context where you can actually do visual programming right on there. You can do all kinds of interesting things. So I'll do something extremely simple here just to give you an idea. I'm going to take two of these principled shaders. Let's make the first one yellow or green or something. And then let's say I wanted to mix two things together. So I want something that's really metallic. But I want to mix it with something like clay. So imagine having dirt on top of something, right? So you've got a car that gets slowly covered in dirt or something like that. How do you layer these things together? Well, we have basically what are compositing operations inside of our shader network. So I can just put down a node called layer mix, hook up the layer to this first guy. You can see they're color coded, by the way, these little orange sort of blocks here. I'm just going to apply this shader to our object over here and hit render. And so to start with, we're going to get sort of a weird mixture of those two shaders together because I literally just sort of 50-50 mixed them. So see, I go one way, it goes to the greenish shader, and I go the other way, it goes to the blue shader. So, okay, so I want to mix these in a more interesting way. So just very simply put down, let's say, a checkered filter. I'm going to plug that into our, into our alpha here. And let's change the checker frequency to like 1 and 1 or something. Oops, maybe 2 and 2. There we go. And so now we're actually mixing between two completely different shaders, all in one sort of lighting calculation. So I'm going to make this like a, I don't know, a grayish color. And I'm going to take away all the reflection and turn the roughness way up. And so you can see completely two shaders now mixed together, all on one object like this, using basically compositing techniques. So artists can use this, and TDs can actually get inside all of these nodes and do interesting things. You know, they can make their own ways of mixing things together. So I think that's a very powerful workflow for both artists and TDs. And so just to end off here, because I probably don't have time, I think I'm out of time to actually show you any more of the other features. I'm just going to really quickly just play this sneak peek video, and that way you can actually just get a feel for some of the things I didn't get to talk about. Scott. If you want to ask me anything about Houdini in the future, please do. I guess I'll be around all night, so just come up and ask me something. So thank you very much.
Yeah, thanks a lot, Scott, for this very nice presentation. And yeah, we'll have a short break, and then we go on with Max.